In this lesson, we're going to look at negative exponents and zero exponents, or when the exponent is zero. Our essential question, how do we make negative exponents positive? So be sure that you are able to describe the different situations of how to make an exponent positive. Okay, so as we look at this, we have two new rules today. We have, first of all, zero exponent. When the exponent is zero, it's actually really, really simple. A to the 0 power equals 1. Anything to the 0 power is 1. Simple as that. Y to the 0 power is 1. 5 squared over 5 squared. Let's talk about that. We would say 2 minus 2, right? And we would say that that's 5 to the 0 power. We might just completely cancel it out. That is equal to 1. Why is it 1? You're saying that doesn't make sense. Well, let's think about this. This is technically 25 divided by 25. And any number divided by itself is 1. Right? So anything to the 0 power, anything divided by itself is 1. That's it. That's all you have to know about zero exponents. Then we have negative exponents. Okay, now this is where it gets a lot trickier. And what I want you to see here, here's our algebraic rule. Okay, so what I want you to see here is that if I have a to the negative n power, okay, this is basically saying that that is in the numerator. All you have to do to make that exponent positive is move its base and its exponent to the denominator. And when we move it, it changes the exponent, only the exponent, to positive. If we have our negative exponent in the denominator, all you have to do is move it to the numerator, and it makes the exponent positive. So all we're doing is we're moving the base with the negative exponent to the opposite place. And what I want you to see is that the base stays the same, meaning the base doesn't change positive, negative, but the exponent does. Okay, let's go through a bunch of examples here. Okay, a bunch of examples so that we can kind of think through this. So x to the 5th times x to the negative 7th. Now, if I was doing this problem, I would start by putting this together. 5 plus negative 7 is negative 2, right? Okay, now this isn't simplified because we have negative exponents. We don't ever want to write this with negative exponents. So what I'm going to do is I'm going to put this over 1 to make it a fraction, so I'm thinking fraction. And all I have to do is move the x to the denominator. Now, what I want to tell you, I want to stress to you, we are not flipping. We are not flipping the fraction. It looks like that right now, but you're going to see in a minute, this is not flipping. We only move what has a negative exponent. But we do need to put something here to cut in the numerator. So it would be a 1 there. Looks like we flipped it, but that's not what we're doing. Okay, let's look at the next one. If we put this together, add the exponents, that would be x to the what? X to the negative 13, right? Okay, so again, I'm going to make it a fraction just so I can visualize where I'm moving this. Base x has a negative exponent, so I'm going to move it to my denominator. So it's now x to the 13th, and I'm just going to put a 1 there to hold its place. Okay, let's look at number 3. A couple of different ways we can think about this. We can add the exponents, or we can just think, well, x to the 0 power is 1, and x to the 5th times 1 is just x to the 5th. Either way, that's how we're going to get it. Okay, number 4. This time, our exponent is in the denominator. Now, what I'm going to tell you right now is that 3 to the negative 2 power does not mean negative 9. You cannot calculate this with your mind without making it positive first. Okay? So what we need to do is we need to take our base 3 and we need to move it to the numerator. So when I move it to the numerator, it becomes 3 to the positive 2. Now, I don't need a fraction because there's nothing left in the denominator. And what is 3 to the second power? 3 to the second power is 9. Okay, let's look at number 5. Okay, a couple of different ways we can do number 5. I'm going to show you 2 ways. Okay, number 1, we can make our exponents positive first. So that means p to the negative 8 has to move to the bottom. P to the negative 11 has to move to the top. So as I move each one to the opposite place, its exponents will become positive. Now I'm going to subtract my exponents. 11 minus 8, notice I have more on top and I'm saying 11 first, so all my p's are left in the numerator. Okay, so that's one way to do it. The second way to do it would be to go ahead and subtract the exponents first. Negative 8 minus negative 11 is positive 3, right? I said negative 8 first, so p to the third is left in the numerator and there is nothing left on bottom. So a couple of different ways you can approach that, and it's totally up to you in how you feel most comfortable. Okay, let's look at number 6. Notice on number 6, we have a negative exponent in the numerator and a positive in the denominator. Again, more than one way can do this. We can subtract the exponents first, or I can make my exponent positive and then move it. I'm going to suggest going ahead and subtracting the exponents. And I'm just going to say negative 5 minus 5. I said negative 5 first. That gives me negative 10. So that means in my numerator, I have x to the negative 10. Now we know we can't have a negative exponent, so I'm going to make this a fraction, and I'm going to move that base to the denominator. So this would be 1 over x to the 10. Okay, now getting even trickier. Number 7. We have a lot of bases here. We have base 5, z, x, y, all this good stuff. We have, what, 1, 2, 3, 4 different bases. Okay? So what I want you to see is that the 5 does not have a negative exponent on it. So the 5 is not going anywhere. He's totally happy. Z to the negative 4, though, does have a negative exponent. So it needs to move to the bottom. And it becomes z to the positive 4. Okay, let's look in the denominator. X has a negative exponent. So it gets moved to the top. X to the positive 2. And then notice y to the third. It's hunky-dory. It doesn't need to do any changing. Okay, and there's nothing else. Everything is taken care of. Okay? Okay, number 8. Lots of different ways. Again, there's always more than, sorry, this keeps unfocusing. Lots of different ways we can do this. We could move this whole thing to the bottom, but I think most of you are going to be comfortable applying this exponent first and getting rid of those parentheses. So let's do that. So this is power to a power. Negative 1 times negative 4 is positive 4. 3 times negative 4, negative 12. And then on bottom, x to the third, y to the third. Okay, now, again, options on what we can do. We can subtract our exponents on our like bases, or we can move things around and then combine them, but let's just keep doing the subtraction. So if I say 4 minus 3, that gives me 1, and I said 4 first, so that goes in my numerator. Okay, and then I'm going to do, and again, it doesn't matter which number you say first, it's just whatever you say first, that's where you put it. So if I say negative 12 minus 3, that gives me negative 15, and I said it negative 12 first, so it goes in the numerator. But I'm not done, right, am I? Because I have a negative exponent. So now I need to take this and I need to move it to my denominator. So this would be x over y to the 15th. Negative exponents are difficult, and we're taking all of our rules and putting them all together.